Hi guys, hello. Today we're talking about the nature of roots, and as per request, I'm gonna try to go slowly into this and sort of like really try to plant an intuition in how you think about these, and try to plant an understanding. So we've dealt with roots before, so you would have x squared minus x is minus 6 is equal to 0, and you would have to find the roots, right? But now we're going to be looking at the nature of roots, right? So what we're looking at is going to be a nature of roots. So I'm really going to make this first video an introduction, right? Just to sort of like look at what they mean and what can we do with them. So what are we talking about exactly when we're talking about this nature of roots? So if you look at what the diagram that we have over here, you can see that A has roots, obviously. When we're talking about the nature of roots, we're looking at what kind of roots does A have. So if you look at A has two unequal roots. You would have minus 3 here and plus 3 there, right? So you will have yeah, right? So don't worry about that question. I found this on the internet, and yeah. So if you look at B, what kind of roots does B have? It looks like B has imaginary roots, right? What kind of roots does C have? C have two equal roots because the turning point is on the x-axis, so it has two equal roots. D seems to be the same as A, where you have two unequal roots, right? Really, that's when that's what we're talking about when we're talking about the nature of roots. We're talking about what kind of roots are we having here, right? I would like to say more about B. So we say B has imaginary roots. Do you see? I didn't say that B doesn't have roots. I said B has imaginary roots. Why did I say that statement? Because B actually does have imaginary roots, but they're imaginary, so we need a different sort of like diagram to help us, understand what's happening. I hope it's this one. Yes, it is. So, if you look at that, we have f of x is equal to x squared plus 1. That's a function. If you look at the edge of the red part, that would be the function. That's that. Now, when you look at it and you forget about the stuff that's coming out of the page, you would think that there is no roots, but actually there are roots. It's just that they are imaginary roots. So this is sort of like the imaginary plane coming out over there, and that function does cut. But because our restriction is just on the paper, we are restricted on the paper with x and y, that's why we don't think and deal with those guys over there. But I want you to understand that they are there. In top of just understanding, I want you to understand that in other disciplines, these, and I'm not talking about roots now, but I'm talking about imaginary numbers, right? We do talk about imaginary numbers, right? So I study mechanical engineering, and it's very difficult to think of imaginary physical things in mechanical engineering. You can't have a velocity with you can't have a real velocity part with an imaginary part. You really can't. What would that, what are you doing? Are you traveling in the what's happening? Are you traveling in the real axis and also traveling, if you look at this, if this you represent y as, if you're throwing a ball upwards, so y is really going to be a displacement in the y direction, and you also have this imaginary part, right? This imaginary part is definitely different from the what you could think of as z, which is the third dimension. It's not the third dimension. So if you're throwing a ball upwards and it's going upwards and it comes downward, if you have the imaginary part, what's happening? It's very difficult to think of it. Are you moving the ball in the y but at the same time it's also going in the image. It's very difficult to have such a thing. In fact, we don't have it in mechanical engineering. And just to be clear, or to protect myself, I haven't encountered something like that. But yeah. But it turns out there are people that do have things like that, and that those electrical engineers. They deal with abstract maths, hey? So electrical engineers would have something like this. Okay, I'm sorry you can't see that picture properly, so I'll choose this one. Right, so this is really the resistance, this is the resistance, right? So R, as you know, so we're dealing with electrical, sort of like engineering. So this is really gonna just be resistance over here, and that's the real part of the resistance. But you can also get an inductive component or capacitive component, and that together is called impedance. And impedance is something just like resistance. So when you deal with AC circuits, which are these guys where the voltage is alternating, right? You'll deal with that in physics when with Murendeni, you will talk about that. But basically, in this part of the world, you can have the imaginary part, which is this reactive, do we call it reactance? I think we call it reactance, but it's a capacity. It's the resistance from the capacitive and inductive component, and so together they make an impedance. So I once had a conversation with sort of like a friend of mine, and I was like, you know what? Please explain to me, why are we having imaginary components in electrical engineering? And I was like, it's very difficult to think about them intuitively. Guys, this is a nice picture before I cover that story. So do you see that they actually say real and they actually say imaginary, and that's really your impedance over there. But in any case, let's go back to the story. I was like, tell me, why do we have imaginary parts in electrical engineering? And he was like, and I was like, I'm struggling to think about them. We don't have that in mechanical engineering. You can't be traveling with 2.5 meters per second in the real direction and in the imaginary direction with 2 meters per second. That really doesn't make sense to me. So he was like, you know what? I can tell you what it physically means, and he was like, think about when you're pouring a beer, right? When you pour a beer, you get a foam and you get the actual stuff. And the foam would be the imaginary part. So it looks like it's a beer, but it's not there. And then the actual part would be the actual beer. So that's sort of like how intuitively he made me to think about it. But it's really not my field. So I really, but really that's what we're talking about when we're talking about the nature of roads. We're talking about these guys. What kind of roads are we looking at? So in the next video, we'll go into details and technically of what's happening. So thank you very much, guys, for watching. Bye.